All right, all right. We are live. We have a couple of guys here in the chat writing. Hi everyone. Oh, another decentralized camp. We are still waiting for Igor. He's fetching some water so he can have something to drink while he presents.
Yeah, and so he doesn't die of heat.
Yeah, I'm here now.
Okay,
I will not
good.
turn on my video. I will only screen share because my internet connection is so nowadays. So
Yes,
better.
yes.
Okay, but we can testify it's the real Igor. It's not the ChatGPT with voice capabilities.
As a language model, I cannot confirm or deny it, right?
Exactly. This Igor is where you should respond like, "I'm sorry, but as a large language model, I cannot." Yeah.
Yeah.
Let's give everybody a couple of minutes to appear.
Warm up a little bit. And if you guys have any questions, you can just write on the chat, and we can ask Igor those questions.
Exactly.
There is ZK audio attestation.
So you can like zero proof knowledge your voice footprint. Yeah, that would be nice.
That would be cool.
Well, I can theoretically send a message somewhere on some of the chains that I'm actually presenting right now, but it's too much hassle.
All right, Igor, do you have your water?
Yes.
Perfect. Perfect. Then we can start. The clock is 6 already. So welcome everybody here who have joined to another Decentralized Camp meetup together with Jonas and Igor here. So we are co-hosting this event together with the Developers Bay. Yes, I think Maria is here as well in the audience and watching. Yes, what else do we have, Jonas?
Well, in the webinar format, we won't do as much gossip as usual, but a couple of things that I guess most of you already heard about, but even so, it's good to just comment on maybe, is of course that in the United States, the SEC has gone after both Coinbase and Binance with a lawsuit. So there is, of course, a lot of noise on the webs about that. Exactly, with Mr. Burns, I'm sorry, Gensler. And yeah, this is a very, very high profile case, particularly one against Coinbase. So lawyers are making lots of money, and this will probably take a while to work out. There's another lawsuit, or actually an outcome of one, which can be interesting for anybody who might be working in a DAO. There's a DAO in the United States called the Uki DAO, which is like a decentralized derivatives exchange, that was recently sued by the CFTC Commission, Commodities Trading Commission in the US. And there was a ruling in that lawsuit where they ruled in California that a DAO can be considered a person and therefore can be sued. And it was considered an what was it called?
Unregistered asset or
an unregistered association or something like that, unassociated general partnership, whatever. I don't remember the term. Important thing is being that every member can be unlimited liable for what the DAO does.
Scary.
So, very scary for DAOs. So that if you're working in a DAO and voting in a DAO, it's just something to be aware of, that the legal risk just went up a little bit.
So does it mean that the United States could actually like sue you if you do anything with citizens from the United States in a DAO?
In theory, they claim that if the DAO has US members, the US has jurisdictions over the DAO.
Yeah.
So that's kind of weird, but it's one case. But the first case is often guides subsequent cases. So I think this is pretty important.
Exactly. So some details about this big suing game going on in the United States. We have SEC that sued Binance and Coinbase, and it's kind of shaky the crypto market right now because of that. We have seen a lot of volatility, and it's quite red on CoinMarketCap. What I have seen is that the SEC have like 13 civil charges on Binance. They accuse Binance of secretly moving billions of dollars of customer funds between companies that's controlled by Xiaopeng, the CEO of Binance. Yeah, a lot of things going on.
Yeah, one highlight, which I don't know if everybody saw that, but there's a chat from 2018, I think, where the then chief compliance officer of Binance said, "Bro, we're fucking operating in an unlicensed securities exchange in the US," in a chat, internal chat, which is part of the court case. So that's kind of Binance, not great for Binance.
Exactly. And we also saw that in this filing. I think they stated that 10 other cryptocurrencies are security. They said, like, I think it was Solana, Cardano, Polygon, Filecoin, Cosmos, Sandbox, Decentraland, Algorand, Axie Infinity, and Kotti. So they are mentioned as securities in the filings, I think.
Yes, but not Ether, which is kind of funny. So well, that remains an open story. Funnily enough, I read an article this morning that the regulators in Hong Kong, which is part of China, are pressuring banks to work with crypto companies. So you know, when the US goes low, somebody else goes high. I don't know. Maybe that's just one anecdote. But
the same is happening in Japan, I think. Well, not exactly the same, but they are pushing towards more friendliness towards crypto companies and simpler regulations.
It's a classic,
especially towards NFT, which they actually what's interesting in Japan, they have NFT as a separate category of crypto assets. Like that's totally different, like legal structure than anything else on the blockchain.
Interesting. Yeah.
But I think that's enough of the legal stuff for today. Anything else you had, Chi?
Nothing. Nothing more than that. Maybe we should give the word to Igor Mandrigin. Is it? Did I say it correctly? Igor Mandrigin, CTO. Okay, CTO of Gateway.
In some countries they do. Yeah.
Yes. So you are CTO of Gateway.fm and at Core Dev on Erigon.
Yep. I'm already on stage.
Yeah, so take it away, Igor, and we'll fade into the background. If you have any questions during the presentation, please shoot them in the chat. And I don't know, Igor, if you want to address them straight away, then we can ask you at any time, or if you want to gather it until the end, as you prefer.
Yeah, I think I'll try to watch the chat room, because overall I can talk between 25 and 40 minutes, depending on the questions. I mean, I can have more of my presentation, less questions, but I would prefer the interactivity. So if you have any questions, I would really prefer them as soon as possible. And then I cannot share my screen until I think you guys stop sharing from your side.
Okay, so I will stop sharing and let you share the screen.
Yeah, let me try. Yep, now I see this. Now I can do it like this. And I'll share it, and I'll try to
I think, we can just disable video, right? So everybody sees a bigger screen.
Yes.
There we go.
Yeah, you see my screen right now. The whole.
We see your screen, the whole screen.
Yes.
Amazing. Yeah. Cool. So today I want to talk a little bit about Appchains on Ethereum in particular. And first you already started with some introduction, but basically, my name is Igor, and I'm the CTO and the co-founder of Gateway FM. More of this a bit later. I was a core developer on Ethereum since I think couple of months. I'm not anymore. I decided to focus more on Gateway FM and its endeavors. And Gateway itself as a company, it's a core developer in Gnosis chain, and one of the currently, there is no essentially core development team on zkAVM on the Polygon side, but we are kind of working with helping with nodes on the Polygon side. Apart from that, we have this infrastructure service that has quite a lot of free and public RPC endpoints for developers, and paid as well if you want some good tech support and something. We are based out of Norway, like the company, and the data centers are independent around the world. And you already see that we have quite a few quite nice clients using us in production for because we are pretty good at being fast and don't crash. And also we have quite a good free tiers, let's put it like this. So up to 60 requests per second on some chains, and up to like I think 100 or maybe even more on some other chains. Like, and Gnosis, for instance, if you use Gnosis chain in any way, most likely you use our infrastructure, because under the hood, everything that Gnosis provides as Gnosis is our infrastructure as well. So enough shilling of the company. Let's go to the actual topic. So today I want to talk basically a little bit about the Appchains, and more specifically on Ethereum, and I'll mention why, and even more specifically about basically using layers 2 and layers 3 as Appchains. And in the meantime, I'll try to explain kind of in depth about how these rollups, especially ZK rollups, work. So hopefully that's gonna be interesting. And later I will just share like where we are now with this kind of approaches and where we are heading, both in the industry, in this part that I'm kind of familiar with, and in Gateway in particular. And since I cannot see the screen with the chat room, then
we have one question here.
Yes.
Oleg wonders, do you use public cloud providers for your infrastructure?
Mostly not. We are agnostic, but everything that we have as public goods, it's independent data centers in Sweden and Switzerland right now. For some clients, we do use GCP and AWS, but that's more the requirements of these clients. So we try our best to avoid public cloud, because there are enough players apart from us who are running nodes in public clients. And that's especially important since we are doing staking as well, and we running quite a few validators on both Gnosis chain and Ethereum, and we are trying to make sure that they are diversified in both geographical terms and also in kind of organizational terms. So there is no single organization that can take over everything.
Excellent answer.
Right. So let's start with the Appchains. And that's going to be a relatively quick topic. So what is an Appchain? It's basically when you want one blockchain per application or for maybe a couple of applications. Maybe this blockchain is public, maybe it's private, and it's tuned for the needs of this application, right? That's your typical Appchain thing here. So why would you need these things? And there are quite a lot of answers to that, but if you try to generalize it, it's when the blockchain world meets the real world. It could be very useful. And by this, I mean that's the things that I wrote on the screen, for instance. You might be under a certain compliance regime that you need to store a certain data and it needs to be private for a certain time and it should be stored for a certain time, things like this. It might be a pure performance thing because if we are doing DeFi and we are not leaving the blockchain itself, then like confirmation times and like finality, reworks, all these things we kind of don't care about. So let's say I'm sending my transaction and it's getting included into the blockchain, but then something happens, the blockchain gets reorganized and my transaction is not there anymore. If everything I'm doing is just interacting with the same smart contract on the same chain, it's no big deal, right? It's fine. But if this transaction is me buying a coffee in Starbucks, then okay, I got my money back and I got my coffee already, and it's not a great solution. So that's where these kind of specific things for, let's say, performance, inclusion, finality can come. Also like privacy and security, because again, maybe you don't want every transaction of yours, especially small ones, to be available for everybody in the world. One more thing is that maybe the whole token structure, the whole like fee structure of the blockchain, because on Ethereum, like you have to live with this burning of ETH kind of thing. On others, you just kind of send this thing to the blockchain validators, send the feed to the blockchain validators. I mean, maybe that's not something you want. Maybe you want some more advanced mechanics, what to do with these fees. You want to collect them yourself and, I don't know, redistribute them somehow among, I don't know, the players of your game. One of the things that I heard about, for instance, use case. That's where the Appchains that are very specifically tuned towards your specific application could be really useful. And we can also look at the Appchains as the one more way of kind of scaling Ethereum, right? So we had this initial proposal of Ethereum 2.0, the Serenity proposal, when we had this beacon chain. I don't know if you see my mouse here. Can you tell if you see my mouse?
I don't see your mouse, actually.
Okay. Let me try to do the highlighter, right? So we have it.
Now
you
we
see yellow, right?
Yeah,
okay.
Now we see.
Yeah, so here is like a beacon chain, right? And the beacon chain basically has a lot of shards connected to it. And each shard is essentially, it's kind of a public blockchain, and each shard could be different, and each shard could like have some smart contracts or applications on them, right? That was the approach of kind of a Serenity. It was proven to be a bit difficult to implement, let's put it like this. And let me pick a little bit more visible color. Then after that, Vitalik came with this kind of layer 2's approach. So we will do rollups. So we have like Ethereum in here, right? Like a layer 1. And then we build up this kind of a public rollups. Maybe the first one is Optimism, the second is like Arbitrum, the third one is like Polygon ZKV and whatever. And then this kind of a public rollups is where the apps are. And if you need even more performance, maybe you do like rollup on top of a rollup and call it a layer 3. And this could be a very specific one. And you run some applications there. But what's important here that each of these L2s and L3s in this scenario, each of them is kind of a permissionless. Anybody can join. Ideally, they should be like decentralized, blah, blah, blah. So each of them basically is another blockchain that you can use. And then another approach is basically to have this layer ones as Appchains and layer twos as Appchains. So we have this one layer one here, Ethereum again, and we kind of run the Appchains, and each Appchain is connected to a certain application here and there. And then these Appchains could be public, private, semi-public, things like this. So we can look at this as kind of a one more approach or one more flavor of the scalability solution for Ethereum. And of course, what I need to mention here, I mean, I'm not focusing on Cosmos, Polkadot, and Avalanche, but Ethereum wasn't the first about Appchains, even though this like by far, right?
Yeah.
Even though this topic is getting a little bit like hot right now, and you can think that it's reiteration of kind of a enterprise blockchain 2.0 on Ethereum, but like projects like Avalanche or Cosmos or Polkadot were there like a while ago. And then we also had these projects like Polygon Supernets, Optimum Superchains, whatever, that are essentially an Appchain approach that are also like alongside Ethereum, but not exactly on Ethereum. Why I'm not looking into like Cosmos, Polkadot, and Avalanche here is because of some properties of Ethereum, like unique properties of Ethereum that I will mention a little bit later. But I think that Appchains of Ethereum could be, let's put it like this, a better way to scale Ethereum and to use this kind of a Appchain approach. And I'll tell a little bit later why exactly.
I have one question.
Yes.
So these Appchains you are mentioning,
Yep.
would you say it's more similar to layer 2 solutions or side chains, which is like most like similar?
Yeah, to some extent, if we go back here, right? In here, we can call them L2s, right? I cannot draw with the mouse, but like this is an L2, this is an L2, right?
Yeah.
Side chains is a little bit of a different thing because side chain is basically you have this layer one in here, right? You have layer one here, then you have your totally independent chain, like I don't know, we call it S or 2, whatever works for me, and you have a bridge here, right? But this this thing, it has its own consensus, it has its own validators, it has its own everything. And in theory, if you like remove this part, I mean, you will have a totally separate blockchain. If you take a Polygon POS chain, for instance, you just remove this bridge, and like Polygon POS is a totally separate chain, nothing to do with Ethereum whatsoever, right? So that's an L2 is actually tightly connected to the base layer, and that's what I'm gonna talk about right about now.
Yep, perfect.
Right. I would say that if we want to look at the proper layer 2s that we can actually call layer 2s, they basically there are two, well, a little bit more than that, but there are two major categories here, like rollups and validiums. And if we're talking about the rollups, what the rollup is basically when you have a chain, again, it could be like a blockchain-ish structure that runs on top of the layer one, let's say Ethereum, and it has a smart contract on Ethereum, like here, the smart contract, right? And then if it's a rollup, then it has to send two types of data onto the layer one, onto the smart contract, or a set of smart contracts. Of course, it's in reality, it's not one contract. It's like more complicated structure than that, with proxies, upgradabilities, management, blah, 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 blah. So first thing that it needs to send is, I will start with data availability. Is data availability, right? The data availability means that if you remove this layer 2 completely, like if if it disappears, then just using this smart contract, you should be able to restore the whole state of the layer 2. That's kind of the data availability part. So rollups should use data availability on layer 1. So it has to be there. And the second thing is a proof. And which kind of proof is a little bit kind of a different story, depending on if you have optimistic rollups versus ZK rollups. But let's just remember that there is a proof here, right? That's a rollup, right? And if you want a layer 3 rollup, let's say you want a layer 3, then basically you have some kind of a layer 2. It could be a rollup or Validium or something. And then you do the same kind of structure in here, right? So you do another layer 3, and it uses the both proof and data availability into the base layer, like let's say layer 2 in here. Then another big thing is that, okay, rollups are great, and they are kind of the safest approach to the layer 2, but one problem with them is they're expensive. And the biggest expenses actually comes from this on-chain data availability. Because you essentially need to store a lot of data, no matter how compressed, but you need to store a lot of data into layer 1. So what if you don't? Just like ignore this completely. Then you are becoming a Validium. So what Validium is just sending some kind of a proof that gets validated in the smart contract on the layer 1, on Ethereum, for instance, or something. And then it has like a data availability. It's called local data availability. Maybe you heard it. So basically, if I, for some reason, will stop as an operator Validium, there is no way you get into the state, to the latest state of this. And if you look at, there is this website called L2s, I think. It actually shows which layer 2 is which. Basically, it shows which is Validium, which is rollup. There is also a volition there, which is another more esoteric version of this. But this too is what you need to remember. And you need to also remember that if you hear the word rollup, immediately you need to ask about how do they store data availability. If they don't, or if they tell you that, oh, we have this off-chain data availability committee or whatever, that means that it's not a rollup. It's a Validium. And it has more risks, but it's cheaper to operate. So a lot of people are wanting to use those ones. So for instance, if layer 2 sends data availability to like a group of people in here, and this group of people is also like getting some money or something for that, then this means that it's not a rollup, it's still Validium, but it's a little bit better Validium than just having quote unquote local data availability when it's just in the database here. All the state, and you cannot recover it.
Can you mention some chains that are using Validium and some chains that are using rollup?
I know that for a fact that StarkX was mostly Validium, but it had a rollup mode, but almost nobody used it before
Okay.
that. I would say that Polygon ZK-VM is definitely a rollup right now. ZK Sync Era is definitely a rollup. And optimistic rollups, I'm not that interested in. I will tell you later why, but again, they didn't, to my taste, they didn't deliver on the promise. But I would say that, yeah. But look at because almost everybody will tell you that they are rollup, even if they are Validium. So the tricky question is you need to ask them about data availability and then see what kind of an answer they can give you to cut through the whole. Okay, then the proofs. So we have two types of rollups or Validiums, as you know it. One is called optimistic rollups and another is called zero knowledge rollups. And the principal difference between them is this part, the proof, right? That's what's different there. So optimistic rollups, by default, they trust everything that happens there. So you send a transaction, and basically there's maybe a single sequencer or maybe multiple sequencer, but whatever sequencer came up with, that's the order of transactions. And you kind of get to the state, and you don't really care about the state until somebody wants to challenge you. And that's where the fraud proofs come to kind of to life. So basically, if you are an optimistic rollup, then the rollup only has to prove that something went wrong, or you have to prove to the rollup that something went wrong to kind of remove the invalid state transition. But it's trusted by default. And what the issue with that is that it's not really implemented anywhere. So neither, I don't talk about Arbitrum. Arbitrum is much closer to that, but Optimism definitely was promising fraud proofs for forever, and they don't have them still. And even like there is like non-interactive and interactive fraud proofs, which means one means, I think interactive means that you actually take this these transactions that you think they are invalid and just execute them on layer 1 and see what happens. And then non-interactive, I don't remember what it means. It's some kind of execution proofs, but they're getting very messy very quickly, and in reality they are not implemented almost anywhere. Again, I'm not sure what the latest state of Arbitrum is. I remember that like half a year ago, nobody had fraud proofs. Maybe Arbitrum released something. Again, I'm not that interested in optimistic rollups for that reason in particular. And also, if there is nobody to challenge you, you kind of need to be really, really careful with optimistic rollups, because you need to really monitor, right? If things are going wrong, because it's kind of on you or on some kind of entities in the rollup to kind of a signal and call the police and check the fraud proof for these transactions. I think zero-knowledge rollups are much, much cooler. So one interesting fact about zero-knowledge rollups is that they have nothing to do with privacy of zero-knowledge solutions. What these rollups needs to have is a proof of computation. They need to prove that taking the initial state, like let's say Alice has 1 Ether and Bob has 0 Ether, after a transaction that Alice sent half of Ether to Bob, the result is Alice has half of the Ether, Bob has half of Ether. As you see, there is no privacy there. But it happened to be that snarks and starks and all this zero-knowledge technology that came from Zcash, that's the best way to produce this succinct proof of kind of a generic execution that we have right now close to production. And that's why these rollups are called zero-knowledge rollups. But in reality, they are just like mathematically proven rollups, if you want, right? So for each transaction, for each state transition, if we're being more technical, in a zero-knowledge rollup, there has to be a proof that it was executed correctly. It could be both like a simple transfer, it could be a very complicated smart contract interaction. It still needs to have a proof, right? And that's why we can kind of think a little bit about them being in a multiple generations, because this task, as you probably, it sounds difficult, and it actually is difficult, right, to produce a computational proof, succinct computational proof of complicated computation. That's why the first generation, so-called ZK rollups, which is kind of StarkX and ZK Sync Lite, they've been very specific for the use case. So you can transfer funds there, maybe you can mint NFTs, but there is no general purpose programming language there.
Yeah, but I have a question about these generations. Like I remember from early readings on this that one critical thing was the size of the proof. Like, what has the evolution of the proof size been over time, and how has that impacted the performance evolution?
Yeah, let's put it like this. The first thing that was difficult to do is to prove a smart contract call, because that's why, like, let's say StarkX and ZK Sync Lite at first, they had basically hard-coded to some extent operations that you can do. Then the second generation, like, it solved the problem of general purpose computation, and at the same time you had this advanced crypto schemas that, again, I know something about cryptography, but not as deep to understand everything. But as soon as recursive zero-knowledge proofs appear, and as soon as there are some schemas like Plonky 2, and things like this, you can have a pretty small proof for very generic computation there. And that's what's basically used in kind of a Gen 2. And I call them Gen 2 right now because they have kind of an assembly, right? Both of them, Starknet has an assembly based out of Cairo language. The zk-sync era has its own assembly that's you take Solidity and use their compiler, zk-sync's compiler, that compiled it into an assembly that's not, both of them are not like EVM assembly. They're like totally different assemblies. They are easier to prove. And they basically kind of, but they can do general purpose. You can do asterisk almost any computation there, like Turing complete environments in here in generation 2. And then we have Polygon zk-VM, which is a little bit different because what it did differently is that they are actually assembly and bytecode equivalent to the EVM of Ethereum. So you can compile Solidity with actual Solidity compiler, SOLC, and then just deploy this into Polygon zk-VM. And apart from 2 features, I think it's going to work, but then it's going to be full equivalent in a couple of months or something like that. So yeah, are there any more questions? Or did I answer the question on the proof? I mean, the proof sizes are basically decreased because there are recurrent proofs right now. So you can kind of merge multiple proofs into one.
Thank you.
Okay, so then with ZK, what you get is basically computational proofs and state diffs to some extent, right? And with this, you can recover the state, and you also know that the state was proven at this point in time, which is really, really good because this kind of proof is what gives you the security of L1, as long as, of course, smart contract is correct and verification of this proof is correct. Then, okay, Ethereum actually checked this computation. That means it's good enough. And then also, I'll mixed up the slides. But with data availability, basically, you have also 2 approaches. So one is to publish inputs, means transactions. So basically, what Polygon zk-VM does, it sends to an L1 every transaction that happens on L2, like literally the transaction body. Usually these transactions are pretty small because, for instance, they are just calling some method in smart contract, like transfer or balance of. Balance of makes no sense in a transaction, but maybe transfer or maybe something else. All right, these are being like published on the L1. And if you look at the Ether scan, you can actually look at the smart contract of roll-up smart contract of Polygon zk-VM, and you will see there the transaction that sends these batches of inputs into the smart contract. And the second approach is to publish outputs. That means that you don't have the inputs, you don't have transactions, but you have the diff already. Because the transaction, for instance, if Alice sends half an ETH to Bob, then in the end you have the state diff of Alice minus 0.5 ETH, Bob plus 0.5 ETH, right? So, and that's exactly what's stored instead of the transaction party. Both of them have different kind of pros and cons. In theory, this one is more flexible and to some extent safer for the third parties. And this one, in theory, could be more efficient because if you have like 100,000 transactions to the same smart contract, maybe state diffs are more compact because you kind of merge all of them together. That's just interesting technical details. So now the kind of a transaction life cycle in zk-VM. I'm looking at zk-VM here because that's the one that I'm intricately familiar with. So, but they are similar in all the zk rollups. So first you just send a transaction, right? You send it normally. Then it gets sequenced, means it gets its place in the list of transactions, because unlike layer 1s, which has blocks of transactions, essentially most layer 2s, they just have lists of transactions. Just it's a linked list of transactions in order. So what sequencer does is like puts it in the right place. Then after that, it's getting batched. And batch is a pure optimization technique because, of course, if you publish each transaction, if you publish it for data availability or publish a proof for it, like one-to-one, you will have the same fees as on Ethereum, more or less, because each transaction on layer 2 will guarantee creation of transaction on Ethereum. So what happens then is that sequencer also, or there's a service called aggregator, for instance, and in ZKVM, it creates a batch of transactions, like in some kind of optimal way for the definition of optimal. And then after that, the transaction is sent to data availability. And that happens in ZKVM either if the batch is full or at most after 10 minutes after the transaction is sent. And from here, it doesn't really matter if the rollup is alive or not. You can always recover the state of your transaction, or basically you can always recover the state after your transaction in here, in this place. Then there is like a huge, usually machine that's, it usually requires like, the ZK Syncero is a little bit less, like 64 gigs of RAM. For Polygon ZKVM, like 256 gigs of RAM and more. This kind of a machine that generates a zero knowledge proof. It executes the transaction and generates a proof. And then after that, it kind of sends it to the layer 1, the proof. And the proof is being verified because the proof is easy to verify. It's hard to compute, but easy to verify. It's getting verified by a smart contract from Ethereum. And from here, you also get one more guarantee that whatever state your rollup reports after including your transaction, it's actually true as far as Ethereum concerned. Right, so it just checks so this is after that, and this happens like it depends. Like I think right now it happens every hour on there is this kind of ZK checkpoint every hour on ZKVM. So after an hour you have like the maximum guarantee. But the important part is in reality your transaction is final right about here.
I have another question.
Yes.
Is there some reason why you cannot keep nesting this concept into L3s and L4s and L5s and L6s indefinitely?
You still have this issue of first of all, it's going to be longer and longer until it's you get an approve. And the second is at some point there's like you see that you don't lose any data there, right? Especially if it's a rollup. And sooner or later, if you do it like this indefinitely, then like just the base layer will be spammed by like huge amount of data availability transactions, which is difficult. And also it has the same problem in theory as eigenlayer when if you stop thinking about scaling L1 completely and you only scale through L2s and L3s, and Vitalik wrote about this in a lot of details in one of his latest articles, you might get this economic disbalance when too few funds on Ethereum protect too many funds on layer 3, let's say, or layer 4.
That's an interesting
and then the economic attacks will become feasible. So that's a little bit of history. But right now, I think layer 3s and maybe layer 4s, I don't think it's any issue to make them. Especially for this kind of app chain approach that I'm talking about right now. So, okay. If we are talking about the rollups as a base of app chains on Ethereum, or maybe not only on Ethereum, but you see that there are quite a few approaches already. Super chains, Supernets will move to this approach as well later, or already moving. Let's put it like this. Then there is a project called Saga, there is Avalanche, and there is super chains and tools like what it's called, Caldera, for instance. I think that's kind of create your own optimism rollup. I'm not a big fan of optimism as a stack because I told that like with the fraud proof they didn't deliver, but oh well. Then the next thing that I wanted to address is Appchains are usually centralized, right? And that's what we tend to not like in the community. And I would here play a little bit of a devil's advocate, or I actually think so. That's for the Appchain approach, if we're doing it with the rollups, especially in ZK rollups, we don't need that much decentralization as, let's say, a public rollup or an L1. And why is that? It's because decentralization is not the goal in and of itself, right? The goal of the blockchain usually is to not have a trusted third party, whatever that means. And but that kind of gives it should give the customer the agency, right? So if I want to transact with some of you, there is no party, including like AWS or somebody who wrote the blockchain, that should stop me from doing that, right? That's the initial kind of goal of Bitcoin and Ethereum and stuff like this. So we want kind of two properties. We want to give the customers some kind of agency, and we also need to have the kind of aliveness of the network, because again, if it's only one node, if it dies with all the data. It's not really cool. And I think like with the ZK approach there, I mean, aliveness is still maybe some decentralization is useful just for convenience, but since you have this data availability on layer one, you don't really care that much about the aliveness of the rollup itself. And the agency is there with user because there are proofs. And these proofs, again, there is one more property that every ZK rollup has, as far as I know, and it's called kind of a forced transactions. And these are the transactions that you send not to layer 2, but to layer 1, to the smart contract of let's say ZK Polygon ZK. And this transaction has to be included in layer 2, regardless of what sequencer thinks about it, and the operator of a sequencer thinks about it. And if it's not included, then you can include it. You can run your own copy of this sequencer, and it will include it and send the proof. You can yourself send the proof on the chain, and then if you yourself sequence it and send proof on the chain, then you can always withdraw money back because bridging will work. So there are a few caveats to that, of course. To send these transactions on layer 1 and to have this kind of a nice property of this like agency on layer 1. Layer 1 needs to have these properties, because otherwise they will not like appear out of the thin air, right? So you need to have them somewhere. And then there is certain non-finality period, which I'll talk a little bit more in details.
Can I just ask about that? Like, if I try to rephrase what you just said, does it mean that basically I, as a user, can force sort of a checkpoint down to layer 1 at any time, but I need to pay the gas on layer 1 to do it? Basically, that's it, right?
Yeah, or you can force any transaction you want.
Yeah, exactly.
Basically, you want send my transaction back to me, basically, or something like that. Send my money from layer 2 back to layer 1.
Right,
like,
but is it just that transaction, or am I actually checkpointing the whole L2?
You can, I mean, it's in theory, like with the current incentivization, L2 should checkpoint itself after that.
Okay.
Basically, because that's how the code works. But if, let's say, the operator of L2 just shut down the network because they didn't like what you did, then you can run your own copy and checkpoint it yourself.
Yeah.
So it's, of course, it's a little bit expensive, but you have this option. Like with optimistic rollups, like if your app chain guy shut down the infrastructure, I mean, you are out of luck.
Yeah.
All right. Non-finality. It's an interesting concept. first we didn't have any finality like as a concept, right? We had this idea that, okay, if I send a Bitcoin transaction and then there are 12 blocks on top of the block that included my transaction, it will be hard enough to rework, and we will kind of count it as final, right? Then in Ethereum, it was the same. Somebody had 12 confirmations, somebody had 24, doesn't matter. Then in Ethereum 2, we got this, and in some other stake networks, we got this notion of finality when we actually have an algorithm. In case of Ethereum 2, it's called Casper Friendly Finality Gadget, FFG, that actually marks certain blocks as final, and then you cannot, by protocol design, you cannot reorg them away. So I think that basically on ZK rollups you have the same. So, well, like you have three things basically. First, you send your transaction in, and it's non-final because it's within only the layer 2. But as soon as it gets like as a data availability sent to layer 1, then your transaction is final. You cannot reorg it away. But layer 2 adds one more, or at least ZK rollup adds one more property that is not only final, but then when the proof comes, that the result of the execution of this transaction is also were proven to be correct. Something like this. So it's actually a pretty interesting concept, but basically it's the same. I'm sending a transaction, and within at most 10 minutes, it's like it cannot be reorganized. And within an hour, you also get some extra guarantee in terms of the execution itself of this transaction. And then base layer neutrality and decentralization. And remember, in one of the first slides, I told that I'm not talking about Cosmos and Avalanche that much because I think that Ethereum has some unique properties, and that's where I think Ethereum does have these unique properties, that by itself, Ethereum is like very decentralized. It has a lot of different validators. Again, there are some groups of validators, I mean, and stuff like this, but in general, it has like more than 500,000 of validators. And it has this property that's by itself, like, it's not really censoring anybody. So you can send any transaction, you can deploy any smart contract, and let's say if Infura or Gateway or Chainstack or whoever like shuts down, you can still send transactions into it. And even if Lido will shut down, like with all their validators, you still will be able to work with Ethereum. And that means that if you build something like an Appchain, a relatively centralized Appchain, or as a layer 2 on this kind of a platform, then you have this neutrality. Then you can kind of bubble up, or you can take a little bit from the layer 1. Because then if your layer is like Ethereum, then it actually makes sense for you to send the transaction to L1 to force it on a layer 2, because Ethereum will not censor you on this. And the same way, if you properly build an L2, you can kind of get the same properties on L3. Of course, it's a little bit diminishing. I would put it like this, because like jumping from layer 5 into layer 1 means you'll have to do transaction layer 4, 3, 2, and 1, right? So it's a little bit tricky, but still, it's there is some sort of bubbling up things.
Is the ambition of the Polygon one to become a neutral L2?
For ZKVM, yes, but then for supernets, no, because they are more like Appchains.
Right.
And then that's the kind of putting it all together. So I think the best way to have like a build Appchains for this kind of a real world use cases is to use the private ZK rollups. And then you have like a lot of nice properties of Appchains, but then you have agency and liveness of some like a big portion of liveness and agency of the layer 1. There are some caveats, of course, to this. They are mostly related to money. It's expensive to generate proofs in terms of the compute time. It's expensive to send the data availability transaction onto layer 1. And also, it's not that expensive to send proofs, but still, if you want send proofs often, it might be pretty penny as well. And then there is some kind of a liquidity fragmentation. Thank you. So these things are basically, trying to be solved by different compressions, improving algorithms and stuff like this. But liquidity fragmentation, I want to show one interesting approach called, it's actually a type of here, L2 bridge. I think it's here. It's basically built into Polygon zkVM. It's a way of bridging funds back and forth. And what's cool about it is that it has only one single, it needs one smart contract on each chain, and it's kind of generates a network of the chains. And what's interesting property of it is that then you can kind of swap liquidity, especially ERC20 tokens and NFTs. You can swap them across any of these chains. So not only from layer 1 to layer 2, but for instance, from Appchain 1 to Appchain 3, or from zkVM to Ethereum, or from zkVM to Appchain 2. It's implemented in the protocol. So it's actually uses zk proofs of zkVM itself to kind of unlock funds on layer 1. That means it should be pretty safe.
So how does that bridge contract work? Like, does it need any liquidity, or is it actually an atomic bridge operation, or what is the mechanism there?
Yeah, it's basically for the ERC20 tokens. It's typical operation when I'm sending some ETH here, for instance, and I'm getting a wrapped ETH here if I'm sending it that way. Or if I'm wrapped ETH here, I can get wrapped ETH here. For ERC20 tokens, you don't even need. You need to deploy the contracts, of course, to support those tokens. But it's I would say up to atomic. It's a bridge operation that's getting confirmed when the next zero knowledge proof comes, because this zero knowledge proof also validates the bridge operations. And it's since it's built into the protocol itself, then it doesn't really need because the smart contract of zkVM here contains it works with the bridge, so that means that it shares some proofs with it. So yeah, I'm not sure.
But I mean, you don't need to deposit a bunch of liquidity into that contract in order to facilitate bridging.
No. You just send whatever, and it gets minted on the other side. So exactly what you sent, like half an ETH and half of wrapped ETH will be there. Again, it's a pretty cool technology. Unfortunately, not enough documentation is there yet. It's based on some, again, Merkle trees, sparse Merkle trees of states in each chain that are then getting proved by the zero knowledge proof.
Oh, well, that's really good news, right? Because I mean, I think everybody who has used first gen bridge knows the feeling when you send it and you don't really know if and when it's going to appear on the other chain.
Exactly.
Yeah. So, I think the thing is that if you're going from layer 1 into layer 2 with this bridge, it's very quick, like it's the next block or something. If you're doing it back, then I think you need to wait for the next proof. So it's a little bit of a delay. But since there is a goal, at least for the public zkVM, to send proofs more often, then it's going to be faster. So right now it's more for safety, right? So, you'll have to wait for, I don't know, half an hour for your funds to actually be retrieved from.
Right, but it's atomic, so you know that it either goes through on both chains or not at all, right?
Yeah, exactly.
That's the important property. Okay, that's cool.
It sounds like multi-chain when it's like that.
It is like I would say that the good thing in here that it's the power of this part is that it's built into the protocol of zkVM itself, so it doesn't need some extra services or extra proofing. So it's the same sequencer on zkVM that does that kind of sequences your transactions and executes your transaction. It also mints tokens if needed.
Yeah, so we got a question on the chat here from Angelica asking what is supporting the bridge. Maybe Angelica, if you would like to maybe explain the question a bit more.
Yeah. But this bridge is also like the downside of it is that it's between Polygon ZKVM implementations, at least right now, and because it requires part of it to be a part of the protocol, which is nobody else, as far as I understand, integrated.
All right. So
yeah, just have 2 slides.
Couldn't do it to another EVM compatible.
Yes.
chain.
Yes.
Okay.
Yes. So that's a little bit, that's a downside. But since we're talking here about the one of the approaches, there are some other ZK bridges that use some other technology in addition to information from the chains. But this one is a little bit elegant. Okay, so then a little bit of a future.
I think Angelica has specified more information here. She says, I am just thinking broader, as in the governance aspect of the contract.
The governance. Right now, the only governance operation that's in here on the layer 1, it's including a new installation. That's the only governance thing. And it has, I think it's under control of Polygon right now, but it has 14 days period. Like if you're feeling something fishy is going on, you can always have 14 days to react to that. Otherwise, it's not really governed at all that much. Especially on this part, of course, it's governed. Like if I'm deploying my own app chain, I'm deploying my own smart contract there. Like I'm controlling this. On the public ZKVM mainnet, I think it's the same. It's controlled by the core devs with 14 days delay period before the changes are applied. Hope I answered that question. So this is Polygon core devs. This is whoever runs this app chain. Okay, 2 slides about the future. The first is that Supernets is switching, that's the news from Polygon. Supernets are switching to ZKVM for all the new Supernets that will be there. So their app chains will become ZKVM as well and participate in this network as well. And we at Gateway are working on kind of a one-click deployments for not only the rollups, but kind of the whole thing with bridges, dev tools, block explorers, and things like this as a kind of a next iteration of Gateway. If you want an extra service, when you can run your own app chain in hopefully a couple of minutes with the testnet, mainnet, and a lot of things like this. Since we're out of time, I will not talk too much more. Yeah, we'll get some pretty cool things like, again, multi-sig bullets, account abstractions, and things like this based on, and the technology we're starting with is Polygon ZKVM rollups standalone. Okay, but then I think that's it. Since we're in a region, there is a weird tax here, right? but yes. So feel free to reach out to me, and if you want free RPC, they are here.
Very nice.
That's almost in time.
Yeah.
That is so cool, and I think what would you say about the maturity of this versus the other attempts like Cosmos or Polkadot in particular, who have been around a longer time and maybe made some other design choices compared to the CK?
Yeah, I think like they've been early, so it's good and bad, right? I think that in the same way as corporate blockchain attempts before ZK proofs were a little bit too early, like, the project baseline and stuff like this. I think Polkadot and the others, they are, and Cosmos, I mean, they're a little bit, I mean, it's a little bit legacy to some extent if you compare it to the ability to just generate a very, very succinct proof of the computation and put it on top of a layer that's well decentralized, right? Because I think the big beef for me with Avalanche or the Avalanche, Polkadot, and Cosmos, that if you compare them to, let's say, it's not a beef per se, but like if you compare them to Ethereum in terms of how the properties of neutrality, decentralization, right, non-censorship, I think they are on the bigger risk than Ethereum. And Ethereum is like under scrutiny of everything, right? Right now, Ethereum is kind of everybody is looking at it, but it has bazillion of validators. It has relatively loosely coupled team of core developers with right now, let's say REF joined kind of a core development, and before that Lodestar, right? So a lot of companies. So I don't think anybody has this kind of ecosystem, and to be able to borrow a little bit of that for your app chain is like really, really good property, and borrow it in terms of like literal mathematics that can prove it.
Yeah, no, I agree. It makes sense to build on a big safe base layer, obviously.
Sounds like you can have like a lot of app chains on the L1.
Yes, and with the next changes to the Ethereum, like 4844 with this blob transactions and full dunk sharding, I think, and the state expiry, I think it's there is still L1 will scale more, and it can fit more and more things. Of course, it's still expensive. That's the big problem, right?
Yeah, but will you be able to do other transactions than sending assets between like app chains and L1, or is
at least Alex to a Y bridge can send arbitrary messages, and then it can say like, okay, just call this method in this smart contract.
But can I, for example, is it possible to actually let a transaction span multiple chains like this, or is it not possible?
No, I don't think so. Like I think it's still gonna be a little bit. I think this is a little bit. These ideas were there with I think the dunk sharding approach between shards, like at least to have some kind of a. But it's not an easy thing to do on these things. I'm not sure. Are there any projects that are trying to solve that in any way? Because it sounds to me like a very how to say it, difficult task to do safely.
Yeah, I agree. I'm just thinking a little bit like, if you have a bunch of app chains, right? And each app chain is optimized for its use case. Let's, I don't know, take a supply chain consortium or whatever. It doesn't really matter. And but then when they want to interact with something outside their own chain, then there will be lots of delays, right?
Yes, unfortunately. So far, it's much more optimized. This approach, again, it's optimized to some use cases that are, or I mean, there are delays, but again, for the supply chain, I don't think the delays matters because your goods are not changing its state like, I don't know, 20 times a second.
That is true.
But like, for instance, this use case could be good for in a simple transaction for, I earned some armor in some game and I want to sell it on OpenSea. Or something like this, or I created something somewhere, or for instance, I wanna, and that's actually one of the things we are a little bit involved in, is when you can pay from your multi-sig with the Visa protocol, just a credit card, right? Then it's also, you kind of can send this money to this layer 2 in that case, and this layer 2 is optimized to very quickly settle transactions. Only that.
Right.
So then you send $1,000 there, they appear on your like credit card account, but it's actually stable coins. Like it's like DAI or Euro, ETH or something like this. When you pay, it just gets withdrawn for you from your multisig.
Interesting.
So it's
Oh, it seems Visa is really active in that space. That could be a topic for another meetup. Maybe if you have a good contact in Visa somewhere, that could be a good topic.
Yeah. For me, it sounds like in the future everything will move away from the L1. The L1 will just be the settlement, and like people will create Appchains and L2s and stuff like that.
No, but it has to. If you just want to have more traffic on there, that just doesn't fit. It has to. Otherwise, it cannot grow.
Yeah, we have a little bit like this idea in the like how to say it in Gateway, at least we see it as there are these cables under the sea, right? And internet works between the States and let's say Europe because there is a huge amount of optic cables between them. But these cables are super expensive to service and stuff like this. So when, let's say, I'm sending my data from Gothenburg into Stockholm, I'm not using those cables. I'm using something local. So the same way I see that, okay, Ethereum is these cables under the sea that can connect multiple ecosystems. But then maybe there will be some like ecosystem of Appchains that does this. Maybe it's local geographically, maybe it's local in terms of the use case or something like that. But yeah, overall, something along those lines is the actual future if we want to make kind of a blockchain system like really, really global. Like then each transaction will not fit into this. Like even if you send all traffic of the current internet through these cables under the sea, they will be overwhelmed really quickly.
Yeah, but it's kind of like the layering of IP addresses or whatever, right? Everything's got that structure in the end. Any other questions from the audience?
We have one question from Tao. Does government like ZK rollups? I mean, regulator.
I mean, I haven't seen any issues with that. Just because again, ZK name is a little bit misleading there. It's just like a computationally provable rollups essentially. There's nothing about. I mean, you can build private transactions from that, of course. And then the question is like, which government will like private transactions? Or maybe they will like private transactions, who knows? But I think the Appchains itself is good for government because it can be easily, again, the compliance part and the interaction with government part, the government rules would be much easier to achieve with the customizable solution. So if I'm running my blockchain in Sweden, let's say I don't know, let's imagine that I'm rebuilding Swish on an Appchain in Sweden, right? Something like this. Then I will be able in this blockchain to specify the specific rules for everything that European Union and like Swedish authorities want me, with all the necessary data access or necessary privacy properties. At least not worse than the current system in terms of the privacy. So I see that this approach is actually good for this, but ZK itself, again, it's a little bit if it will get treated by the name like zero knowledge, it might spook some governments. That's for sure.
Wonder what we should call it instead.
I mean, it's but that's like I just remember what's I think Stark, right, or Snark. It's 16 blah 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 something. But basically, we just need to remove zero knowledge. We need to prove that that's a computational proof. But it doesn't sound as good as ZK.
No, there is something to say for cool as well, I suppose. At least to make it cool. Okay. Awesome, Igor. You are our source of much of the groundbreaking stuff going on, which is fantastic.
Yeah. Thank
Definitely.
you.
And I hope the audience had a good time. We will be back after summer with in-person meetups for sure.
Yeah, thank you very much. Thanks for having me. And hopefully see you in person after the summer.
Yes,
definitely.
We have some interesting things planned for after summer. Let's see
Great.
if we can make that happen.
Yeah, keep an eye out on the meetup emails.
Yes.
Yeah, absolutely. Thanks so much.
Yeah,
Bye-bye.
thank you. Take care, everybody.
Yes.
Bye bye.
Take care, everybody. Thanks.